So hi everyone, welcome to the Toronto workshop. This week we are very glad to be joined by Meggie Debnath, who is at St. Mike's Hospital and Unity Health Toronto. Meggie is a data scientist in the Data Science and Advanced Analytics unit at St. Mike's, and basically they provide data science and machine learning solutions across a variety of problems. So I am very much looking forward to this talk, and thank you very much, Meggie.
Thanks so much, Rohan, for having us here today and inviting DSAA to come present. I'll just share my screen. All right, I'm Meggie, and I'm a data scientist at Unity Health Toronto, part of the Data Science and Advanced Analytics team. And so my co-presenter, Maitri, she couldn't be here today because she's recovering from an injury, but we wanted to talk to you guys about a few things that we've learned from deploying AI in healthcare. And when I say 5 things, I actually really mean a million little things, because there's a lot that we've learned and a lot of things that I'm continuing to learn as we kind of work on more projects as we go. But before I talk a bit about our learnings, I'll spend some time introducing our team and the work that we do. So as I mentioned, we're the Data Science and Advanced Analytics team, also known as DSAA. We're an analytics group at Unity Health Toronto, which is comprised of 3 hospitals, St. Joseph's, St. Michael's, which is where we're based, and Providence. And so we work with clinicians and closely with other decision makers across the hospital to develop and deploy different analytics solutions. And the goal with these solutions are really to assist with decision making, and hopefully increase hospital efficiency, as well as improving patient care and outcomes. And just a little bit more about how the DSAA team is structured. It consists of 4 different sub-teams. So we have the Advanced Analytics team that's made up of data scientists that work on kind of the exploration, analysis, and modeling tasks. We also have the data integration and governance team, who are made up of ETL developers, data engineers, sysadmins, and they're kind of the backbone of all of our data infrastructure, and they're the ones that ensure that we can access data securely, efficiently, and in kind of the cleanest form possible. We also have the support team that's made up of research coordinators, and they kind of manage the project's end-to-end delivery for things like structuring sprints or getting research ethics approvals and facilitating a lot of the collaboration with the clinical teams. Finally, we have the product development team, and they're made up of developers that work on the software and infrastructure side of things to help us deploy the tools that we develop. And they're kind of the bridge between the modeling and analytics and the end user side of things. Now that I've shared just a bit about our team, I'll spend the next couple of slides just talking about some of the work that we do and a couple of examples of our projects. But in short, it's a little bit of everything. So some of our projects focus on predicting patient outcomes like patient deterioration. Others are more focused on things like resource allocation or scheduling, like operating rooms, for examples. And the range of analytics solutions that we have are also quite broad. It can be things like statistics to machine learning, to optimization or simulation projects as well. And we've been really lucky to have been able to deploy over 40 solutions across Unity Health, as well as a couple of other locations. And I want to mention that our projects kind of act as a decision support and quality improvement tool. So they're not medical devices, and they're not intended to be like diagnostic in any sense. They are really to provide support, and the clinicians and physicians are really the ones who are making the ultimate decision when it comes to patient care. And so with that, our projects typically involve a lot of collaboration to incorporate any process or workflow changes that we need to make so that so the solutions can be deployed in the clinical environment. So a little bit about a few of our projects. One of them is the Hemodialysis Hospitalization Risk Alert. And the goal of this tool is to send a weekly alert to clinicians for hemodialysis patients who are at risk of being hospitalized in the upcoming month. And the predictions are communicated through a weekly email list that's sent out with patients categorized as high, medium, and low risk. And just a bit about the data for this project, we had about roughly 200,000 observations when we were working on training and testing the model for this project. Another project that we have is the emergency department forecasting dashboard, and this shows estimates of how many patients are likely to arrive at the emergency department in the next few days. And it's also broken down by patient condition and their severity at the time of when they arrive, and the time window that they're likely to show up. The third project I want to briefly mention is the ChartWatch project, which is an early warning system, and it predicts a patient's risk of death or transfer to the intensive care unit in the next 48 hours. And this project was first deployed at St. Michael's Hospital in the General Internal Medicine Ward in 2020, August 2020. And we're currently working on expanding it to other units and other sites at Unity Health as well. And for this project, we also have a commercial partner called Signal One that we're working with. And so before I dive into the things that we've learned, I want to get your thoughts a bit on what do you think are some of the challenges that we might face in healthcare data science. So please feel free to share your answers in the Zoom chat or even out loud. So I'm seeing the data. How do you make sense of doctors' writing? That's a big beam. Okay, so working with data that is confidential, consistency of data. How do you get busy clinicians to interpret your dashboards? That's a great question. So things about trust between doctors, patients, data, and methods, interoperability of various systems. Yeah, so these are all great guesses, and actually I think I'll be touching on probably a bit of all of these throughout the talk today, and just some of our challenges that we've experienced with all of these things, especially data and messy data, and hopefully be able to shed some light on the things that have worked for us. So when we were trying to kind of compile what we wanted to talk about for this talk. Like there were a lot of little things, and we tried to kind of structure it into like 5 main themes. So one is collaboration being super important across different teams in the hospital. Also understanding data sources and how to use them. Next, looking at data and how they can be kind of unexpected from what we want and what they are. And then moving into kind of deployment of projects. So how do we have a silent testing period, as well as how do we monitor projects after they've been deployed? So the first kind of learning is about collaborating with different teams. So DSAA might be the team that's designing and developing these solutions, but really we're just the tip of the iceberg. There's so many teams that are involved in making a project successful, like clinical teams, including nurses or physicians, and other teams around the hospital, including IT or clinical informatics, for example. And it's really this partnership and collaboration that allow our projects to be successful. Some of the things that you guys have mentioned in the chat, like trust and working with different teams, like that's honestly like one of the most important things, because without it, like we might have models, but we really wouldn't have like anyone to use them or any impact with them. So this is a diagram of the process that most of DSAA's projects follow. So it typically goes through an understanding phase, followed by data preparation, modeling, and then developing the ultimate tool for deployment. And it's a super iterative process. So we might go back to understanding, or we might kind of cycle through data prep and modeling. So it's really a cycle, and there are points in the process where we might actually exit if the project's not really appropriate. But typically we receive projects through an intake process in the hospital, where clinical teams submit a problem description where they feel an analytics solution would be beneficial. And because of that, clinicians are involved throughout the entire project's life cycle, from understanding all the way through to deployment and evaluation. And this is something that's really important for us, because it allows us to have subject matter expertise when we're developing our models, so that they're actually representing the problem at hand. And it also makes sure that we are aligned on objectives, and that in the clinical environment, when the models are deployed, it's done thoughtfully and they work as expected. And again, going back to establishing trust, just having end users engaged throughout the process allows for that relationship to form, and for the trust to be established, because they're kind of aware of, how is this model performing? Like, what can we expect once it's deployed in the clinical environment? And one example where this collaboration was pretty useful for us was when developing the ChartWatch project that I mentioned earlier. One of the features in the data is a value from a lab measurement called troponin. And the way that this lab value is measured actually changed in the hospital. And the project team was informed through the clinical informatics team. And luckily, they were able to adjust the data processing to account for this change, and they were able to do it before the project was eventually rolled out. And while the project team might have found out about this change eventually, like having that close and consistent collaboration is what allowed it to be communicated early, and get the details of like what exactly needs to be changed, so that it could be adjusted accordingly. And it might be a small value in like one lab measurement in like a sea of data, but these kinds of things really matter, just having that consistent relationship. And another important collaboration we have is with the hospital's IT department. I saw in the chat, like some of you guys mentioned, privacy considerations. So that's a big thing when working with healthcare data, as some of you might know. We're working with personal health information of patients, so there's a lot of rules and guidelines set by IT that are definitely there for a good reason, despite how annoying it might be on kind of the modeling side of things. So some things that we do, so our project deployments, they sit in the same secure private network as the clinical systems that contain the data itself. So that adds a layer of security. We also work on servers that are not directly connected to the internet. So they work on our local on-site network. And as a team, we've also made certain choices like migrating to GitLab from GitHub. And that allows us to keep our code on the same on-site network as well, rather than kind of just on the wider internet. In our team, we also have some processes laid out for managing things like credentials, especially when there are passwords that we need to share across different platforms or for different services. And finally, we have a member of our team that kind of acts as a liaison between our team, DSAA, and the IT department, and that just helps to streamline communication, since it's something that's very frequent that we have to contact and work with IT. And now on to our second major category of learnings, which is about understanding data sources. And our data sources differ quite a bit across our different projects. Each source has its own considerations when it comes to access, privacy, processing. So we wanted to share some of the things that we're thinking about at this stage of our projects. Also, near the beginning of the talk, I mentioned that we have a dedicated sub-team called DIG, and they're really the experts when it comes to dealing with raw data sources, and they're the ones that make sure that we as data scientists can access data and work with it efficiently. So we work with many different hospital source systems. A project could use, maybe 2 to 3 different source systems to get all of the data that it needs. So some examples include Saurian, which is the hospital's electronic health records. And we also have something called the Enterprise Data Warehouse, or EDW. And that's designed to bring in data from multiple different source systems into a more clean and structured database. And so when we're thinking about appropriate data sources for a project, we've learned that it's more than kind of just, what data do we need, what features are available. It's really about things like, how can this data be accessed? So some things that we think about there are, database connections that are required to access these source systems. And so within our team, we've built an R package that contains some of the common functions that we need to use to access these systems. We also think about personal versus service accounts. Typically in the development phases, we use a personal account, so each member of the team has their own account for that. But then we use a service account when it comes to deploying a project in a production environment, so that if there's any updates that need to be made, it's all in kind of a centralized place, and it doesn't need to, you don't need to, go into someone's personal work laptop to be able to fix a project, for example. Some other questions that we've kind of learned to ask are how often do the source systems update, and how recent the data will be when it's pulled. So depending on the project, we might need data that's updated every 15 minutes, for example. So in that case, we couldn't use a system that's only updating every hour or every day. So that's just something to think about there. And then finally, just thinking about like how long data pulls might take for every time a project is run, depending on how long it takes. Any downstream processes like any data processing pipelines or model inference pipelines, they would need to be scheduled accordingly so they're not, accidentally being run before the data is even there to work with. And the hospital is a big place, and while a lot of the data is captured within the electronic health records and other source systems that I've mentioned, in some cases it's maintained by individual teams on things like Excel. And this is not the ideal data source by any means, but sometimes it's just what we have to work with, especially in the beginning of projects. Like this might be the case where the project is being established and so data needs to be manually transferred over until there's a more formal process that's established. So some things to just consider there are just consistency in the file and format, as well as the schedule in terms of when it's being sent. Just an example here for one of our projects, we work with another hospital in Toronto in order to provide like a ED forecasting dashboard. And so we receive a daily TXT file from them, and that contains their emergency department patient data for the past 3 days. And all of the data processing and dashboard scripts, like they're scheduled on our end. So we need to make sure that we have the TXT file kind of around the same time each day to be able to run anything else that comes after. And I just want to reiterate, like it's not the ideal scenario to be working with these files, but sometimes it's all that we've got. The third type of data that we might work with includes data from external databases or other partners. So this could include provincial level data or other hospital sources like outpatient clinics. And when working with these external systems, we need to make sure that the data sharing is secure and that the connections are reliable, because if you can connect to it and you get all of your training and testing data, that's great. But once it's a deployed project that's running continuously, we want to make sure that the connections can consistently be accessed and this data is readily available. And another thing with external data is just the need to make sure that the data is well understood, and we spend a lot of time trying to get familiar with it. One example of this is working with a database called NephroCare, which is managed through an external vendor, but it's used in one of the hospital's outpatient clinics for hemodialysis. And in this project, we were working with 2 tables from this database that contained the same columns and seemingly the same data, but the tables were very different. Actually, we found out that one of them, the table was being completely rewritten every time the data was updated, and the other one was being appended to. And the one we were using, of course, was the wrong one in our data processing pipeline. So that's a change that we needed to make. But it taught us, we need to really learn about the data and how it's updated, and think about like, is there a data dictionary that we can use to understand the values, and also just thinking about like how to integrate it with other data sources that we use in our projects. And so one of the solutions for some of these challenges has been something called data virtuality that our DIG team has been working on. Essentially, it's a virtualization or like a parallel layer which creates different views of data from multiple different source systems. And it's been really helpful for us because it doesn't impact performance on source systems when we query the data. So we don't have to worry about things like, is it safe to actually run a query and pull the data? Also, the data pulls are a lot quicker when using data virtuality as well. But some limitations is that while it does work well for tabular data and kind of more structured cases, when it comes to imaging or waveform data, for example, we still have to rely on other sources for now. So having access to the data is one thing, but what happens once you have the data? So this next learning might be something that you guys have experienced in your own work, that data is definitely not what it seems. So data is really messy, as you might expect. In our projects, especially working with healthcare data, it has a lot of missingness. So in our projects, it could have up to 15% missing data that we have to use methods to either impute or decide whether or not we just want to exclude that data when we're developing our models. Another thing that is really critical in our data is timestamps. And this is because timestamps are kind of the marker for a lot of patient events. They let us know when a patient has any type of treatment, intervention, or whether a patient has moved to a new location, like from the emergency department to a location on the ward. So we work with timestamps a lot in our data. And one challenge for this has been with daylight savings. I know that no one really likes it when the time changes, and our projects don't really like it a lot either. When it came to daylight savings, like we've noticed a couple of instances in our projects where things looked a little bit funny. Working with like ED data, for example, one of our project teams noticed that we were seeing like a spike in one case when the time changed, and then like a drop in like patient arrivals in the other like reverse situation. And so yeah, it's just something to be aware of. When the time changes, data could look funny. And one solution that we've had for a past project was to work in UTC, in the UTC time zone, when we're doing any kind of processing, and then converting that back to Eastern time when we're displaying any outputs to end users. And just a bit about some challenges within our data here at St. Mike's and Unity Health. We don't really have a lot of demographic information that we would like. We have like the basics, but it would be great to have some more information to be able to accurately assess performance on model subgroups, and just know that we're kind of representing different people. And then also, like when data is manually updated, which is the case with a lot of clinical data, we need to consider whether it's going to be available and updated in time for use in modeling pipelines. One example of this is with the hemodialysis project that I mentioned earlier. We're predicting whether or not a patient is going to be admitted to the hospital. So we don't really want to run predictions when a patient's already in the hospital. So we need to check if like the indicator for whether or not they're already there. And sometimes this is updated manually, and it could be delayed. And in that case, like we might end up, running a prediction on someone who's already been discharged, but we just don't know it on our end because the data doesn't yet reflect it. So in some cases, it's just a matter of accepting that data is flawed and communicating that expectation with end users that, there are going to be some cases where it's not perfect, and we're kind of just working within the limitations here. Also working with data, we know that unique identifiers are really important. but sometimes the expectation with that doesn't always match with reality. So for example, we might expect that there's one hospital-generated patient identifier for each health card number, but what we've seen is that sometimes there's up to 7, for example. And other times, people don't have any health card recorded, and sometimes they have many. So it's a real challenge to figure out what the mapping should be, especially when joining different data sets together for a project. And there's so many different patient identifiers in the hospital as well, and they also could change over the course of a patient's stay. For example, if they're moving from the ICU or emergency department into an inpatient setting, like they could have different identifiers or a new identifier created to represent their stay. So for things like this, we really have to work closely with DIG and teams like clinical informatics to just better understand these identifiers and know how to work with them. So we're not having, a person with 7 health cards in our data set. So the ChartWatch project that I talked about earlier, one of the routine labs captured here is sodium, and it's a frequent lab that's used across a lot of our projects. But we noticed that when ChartWatch was in its testing period, no sodium labs were being counted at all, even though the other labs were fine. And for those of you that work in R, you might have an idea of what's going on here, maybe. So our team uses R very routinely, and in R, the symbol NA usually means not available to represent missing data, but in chemistry, Na is the symbol for sodium. So what happened was that in the data extraction pipeline, it was interpreting sodium as being not available instead of sodium. But luckily, the fix for this was relatively simple once the team noticed. It involved just specifying that they should use an empty string to represent missing data instead of NA in quotes. But just this experience overall just taught us that we need to be really careful when using any symbols or values that might potentially mean 2 different things. And it also got us wondering, are there other examples where certain symbols or terms are manually entered or just used to represent a missing value? For example, like what if like a missing body temperature is just like entered as like -1000, in just like basic data processing without really looking into it, it might just be kind of skewing some of the statistics, but in reality, it's just a way that's being used to represent a missing value. So just something that we've learned to be careful of, just looking closely at data and understanding the context that we're using it in. And of course, soon after that fix, we saw the sodium lab counts return. So with that, we're going on to the next learning, which is having a silent deployment. What is silent deployment? It's typically when we run the entire project's pipelines all the way from data extraction to sending out model outputs in an environment that is exactly like what it'll be in the real setting when it's actually running. The only difference is that we're not sending out any outputs to end users of the tools. And there's a few reasons for having this testing period. One major reason is just to catch any technical bugs or issues with the project pipelines. In one project, for example, we noticed that there was an issue with the database connection to one of the source systems. It was frequently failing and causing that data source to not be available for use. So based on that, the project team decided just to exclude that data source entirely from the project. They didn't see any decrease in performance, luckily, but it's just kind of one of those decisions that needed to be made based on the stability of the deployment itself. Like sometimes it works, when you're doing the modeling and all of the evaluation there, but it might not work in the actual production environment. Silent deployment also has been really useful for us to catch any unexpected behaviors with the data or the model. So the NA bug that I spoke about earlier was caught during a silent deployment period. It's also a chance to get feedback from a small subset of end users and just to like finalize some details about, how is the information presented to end users? Are there too many alerts being sent? Is there anything else that's weird or needs adjustment? This is a great time to kind of make all of those small changes without having it rolled out to everyone, the larger group. And finally, with a lot of our projects that are brought to us, we don't really have a great idea of what the current state is in the clinical environment. So this silent deployment period kind of gives us an opportunity to generate model predictions while simultaneously collecting predictions from clinicians, for example. And then we have kind of two data sets that are predicting on the same group of patients. So we're able to compare those results and see, how does, what's the sensitivity like in the current state compared to our model? Is the model showing any improvements? Is there room where like the clinicians are doing better, for example? So this is a good time to collect that information. So there's this paper that we've recently gone through in one of our journal clubs called Operationalizing Machine Learning. And they did an interview with multiple machine learning folks, just commenting about deploying machine learning and some of the considerations for monitoring and things like that. So one of the things that they discuss is having a multi-stage deployment process and some of the benefits of having like this testing period in terms of identifying any rules that need to be added or modifications for any unexpected behavior for the models. And just some strategies and things that we think about in terms of silent deployment and rolling out a project. We typically consider the outcome rates and the size of the population for a project when we're deciding on how long the silent deployment has to be. In DSAA's past projects, they've ranged from 2 to 12 months, with kind of 6 to 12 months being a typical range. And during this time, we of course have frequent check-ins with collaborators and end users to put any final touches in place for the project. And another strategy that's been useful for fairly large projects is rolling out in phases. So for example, the ChartWatch project, it's meant to serve all of the general internal medicine group. But it was rolled out to individual teams kind of one by one instead of all at once. And this allowed for monitoring in a more controlled way. We don't have to consider everything. It's just whether it's working in individual teams one by one. And just to mention, like, this is an iterative process as well. Like, if we find any issues or bugs, we kind of go back and make those changes. And it's definitely a process that requires frequent revisions before like the final rollout. And then just a bit more about deploying models and how to integrate it into a clinical workflow. What we found in our projects is that the best model is not always the winner. We want to consider things like how simple is the model in terms of deployment, in terms of like how it's going to work. And so we might have a model that's, like a black box model, for example, that performs really well, but we want to double think about that to consider if we want to deploy that. And typically we kind of go towards models that are more explainable and simpler to deploy and maintain. And then in terms of how model outputs are delivered, communicating these outputs are a big consideration that the product development team looks at in terms of human factors and usability. We don't want to just send out, an Excel file or an email with predicted probabilities, because in reality, that's not going to make sense to anyone. So thinking about things like what's appropriate for the project, can we use something like a risk scale where it's high, medium, or low risk to categorize patients, things like that. Another thing when it comes to sending out alerts is how should the alerts be sent or retrieved. In some projects, they're directly sent out to clinicians to their pagers or emails, for example. But in other cases, it's more of like a dashboard type solution where the information is retrieved as needed from the clinical teams. So just having that understanding, and this goes back to collaboration, just understanding how end users want to receive this information and what's the most appropriate depending on the project. And related to that, I just want to touch on briefly, alerting rules is something that we consider in some of our projects where, we might be tempted to, send out alerts for every single patient, but just considering things like alert fatigue, if we're sending out too many alerts, it might not be very meaningful at all. So thinking about things like, if a patient has been alerted in the past 48 hours, for example, maybe we pause on their next alert. There's just rules that we develop in collaboration with clinicians that are appropriate and kind of minimize this alert fatigue that might happen. And the fifth learning is just monitoring everything and thinking about how to evaluate projects and their impact. So monitoring is a really important part of making sure projects are successful, and it helps to identify if there's been any errors with project pipelines, for example. So in terms of monitoring for downtime, we have a few different things in place. We have email alerts that are typically sent out if there's been an error in any of the steps in the pipelines. And so we've built an internal package called Jarvis to help send out alerts and identify at which stage of the pipeline the error happened. We also have Slack integrations with some of our projects where a downtime alert is sent to a Slack channel, and so anyone on the downtime team could respond to that and quickly, make sure that things are okay. In terms of model and outcome metrics, we look at performance metrics typically. So some projects might look at sensitivity or precision, for example. So those might be some metrics that we monitor over time. We also try to look at any outcomes of interest that are relevant to the project. So for ChartWatch, for example, we look at the counts of high, medium, or low risk patients, since that's something that's a direct output of the model. In terms of data monitoring, it's really important to be able to identify if there's been any shifts in the data that might impact model performance, as well as to detect any anomalies. And so something that we're looking into right now and learning about is the point blank package for R. And we're trying to figure out how we can incorporate this into our pipelines for validating data and monitoring if there's been any anomalies. And we're also looking at consolidating projects into dashboards, so similar projects with potentially similar data sources kind of in one snapshot view to look at if there's been any red flags with the pipelines or the data or the model metrics, for example. And so while monitoring the data and the model metrics is one aspect of things, in reality, if no one uses the tools, then there's going to be no impact. So something that we try to think about for our projects is monitoring user engagement. But this is quite challenging because depending on the project, there might not be a direct way to measure if an end user has seen the output or if they've used it or incorporated it into their actions or interventions. In terms of projects that are dashboards or similar tools like that, we can kind of estimate user engagement by the number of views. For other email-based tools, we might have a confirmation button within the email that end users can click, and that kind of gives us a proxy estimate of who's been viewing these alerts. And so this slide here is just an example of one of those types of projects where an email list of patients is sent, and we get an estimate of user engagement through the confirmation of button clicks. But of course, like this is a flawed approach, so it's not really perfect all the time, but it's just a way for us to kind of get an idea of user engagement. So there are a few more things that we wanted to briefly mention that we couldn't fit into the 5, and they're kind of more about documentation and knowledge sharing, which we thought was important to mention. In terms of documentation, this we found has been really critical for long-running projects where project teams might change around. So documenting things like the code, but also project decisions that are made, like any small decisions like, oh, we tried this, but it didn't work, or, you know, we got this feedback from clinicians and we've incorporated it here. It's really helpful to know when these decisions were made and what impact they had. And one of the best ways to do that is through documentation, because there's no way that we're going to remember everything. And it's hard sometimes to interpret it through the code. So something that we've been looking into related to documentation has been data and model sheets. And I'll show an example of that in the next slide, where it kind of summarizes the information about a data set or a model and provides like a quick view of every key element of it. So this is an example of a model card. So it would have details like the model's intended use and the different metrics that the model was evaluated on, as well as information about the data or ethical considerations. And we found that having like a model card for some of our projects has been really useful to just refer back to if it's been a while since we've worked on it, or if we need to communicate any metrics or things like that to end users or other teams. And finally, just a bit about knowledge sharing. We've been trying to move from individual knowledge to institutional knowledge because the team has grown quite a bit over the last few years, and there's a lot of knowledge concentrated in like specific people's brains, and we want to try to get that out and share all of that so that it's, you know, easier for everyone. And some ways that we do that, just sharing knowledge through journal clubs. So we read different papers and talk about any interesting findings or applications for our team. We also have demo days where people, if they found like a cool R package or other tool or package that they want to share, they talk about kind of how it can be applied to our work. We also have deep dives into each other's work or each other's code. So if, for example, like we're working on a project and there's something that we're stuck on, this is a time to kind of share ideas or just help each other through different challenges. And shameless plug, we also have a blog that we've been trying to maintain more frequently, where we share some of our learnings and just things that we're working on as well. And before I end, I just want to give a couple of shout outs to MyTree for contributing a lot to this talk, as well as Derek, Chloe, and Kathy for their support in also pulling things together, and just to the rest of the DSAA team, because I've talked a lot about different projects and work, but it's really a collaborative effort, and all of these learnings kind of come together with the entire team. And thank you everyone for being here today, and happy to answer any questions, and also check out our blog. Thanks everyone.
Thank you very much, Meggie. That was absolutely fantastic. I'll just stop recording.